Hi all, today we are going to discuss about the Aldol condensation reaction. Aldol condensation reaction from the carbonyl compounds. The definition is alpha hydrogen containing carbonyl compounds reacting in presence of diluted base to give beta hydroxy carbonyl compounds. Here, then Aldol condensation, Aldol is nothing but the obtaining compound containing the both aldehyde groups and alcohol groups. That's why we are having the name of Aldol condensation. But this is not a scientist name. This Aldol condensation reaction can be classified into three types: self-aldol, cross-aldol, and intramolecular aldol. Intramolecular aldol is nothing but aldol reaction takes place within the molecule. In this session, we are going to discuss about the only self-aldol. In this session, we are going to discuss about the only one type of aldol reactions, that is nothing but self-aldol reaction. Self-aldol reaction. When 2 moles of acetaldehyde reacting in presence of diluted base to give beta hydroxy carbonyl compound. On further heating, it will produce alpha beta unsaturated carbonyl compound. Here, the intermediate which is formed in the self-aldol reaction is beta hydroxy carbonyl compound. Beta hydroxy carbonyl compound. Here the final product of the self-aldol reaction is alpha beta unsaturated carbonyl compound. This is the major reaction of the self-aldol reaction. Here if you see the mechanism of self-aldol reaction, here I would like to take the one molecule of acetaldehyde like this, CH2 C double bond OH and H. This one molecule of acetaldehyde reacting in presence of diluted base. This base will react with this hydrogen, go out as the water molecule. This bond will polarize here to give CH2 C double bond OH, carbon anion. Here this negative charge will polarize here and it will give the stable enolate ion, CH2 double bond CO bond H. Here it is called stable enolate ion. In the mechanism of self-aldol reaction, this enolate ion will act as the attacking nucleophile. This enolate ion will reacting with the another molecule of acetaldehyde. This negative bond will polarize here and the double bond will combine with this carbon to form the further compound like CH3 CHO minus CH2 CHO. And here the attacking of nucleophile to the another molecule of aldehyde is the very slow step. We know the slow step of the mechanism is nothing but the rate determining step. And for this compound, after further protonation, it will give the compound CH3 CHOH CH2 CHO. It is nothing but the beta hydroxy carbonyl compound. On further heating of this beta hydroxy carbonyl compound, this hydroxyl group will combine with the hydrogen of methylene group, go out as the water molecule, and this bond polarize to give the final product CH3 CH double bond CHO. Here we are calling it as the but2 in 1R or crotonaldehyde. And this is the mechanism for the self-aldol reaction of acetaldehyde. And we have another example. If you take the 2 molecules of acetone, I want to explain another example for the self-aldol reaction. If you feel this is the very long process to find the final product of the self-aldol reaction, I would like to introduce the direct method of the Aldol condensation. Here, what is the direct method, students? Here, direct method is nothing but I would like to take carbonyl group, one carbonyl group like this, and another molecule of carbonyl group like this. Here, bond polarized to oxygen to give minus charge here, here positive charge, and bond will break here to give positive and negative charge. This negative charge here attached and hydrogen attached to give hydroxide group. Here it will give the product C and OH and Z. By using this direct method, I would like to explain the one example for the self-Aldol reaction. Here I want to take the 2 moles of acetone. Here I want to take 1 mole of acetone like this, 1 molecule of acetone like this, and another molecule of acetone like this. Same like in the direct method, I want to break this bond to give the ions here also positive charge and negative charge. This negative charge ion will bind here and this hydrogen will bind to oxygen. It will give the CH3, CH3 and OH, CH2, C double bond O, CH3. For this compound, I would like to write like this: CH3, OH, CH2, C double bond O, CH3. Again, this is the intermediate beta hydroxy carbonyl compound, and further heating of this beta hydroxy carbonyl compound, removal of water molecule, same, and this bond will polarize here to give CH3, C, CH3, C, for a double bond, C double bond O, CH3. We are calling it as the mesitile oxide. Mesitile oxide. And the IUPAC name of this mesitile oxide is nothing but 4-methyl pent 3-ene-2-one. 4-methyl pent 3-ene-2-one. And the common name of this compound is mesitile oxide. And this is the information about the self-Aldol reaction. Thank you.